Hello everyone, in this video we're gonna be talking about compound inequalities. So let's say when you have two or more inequalities together being joined using the word and also or, okay? So if you take a look at this example, we have two inequalities and then there's and in between, and also this one you have two other equalities and there's or in between. So we're going to be explaining how to solve each one and what is the difference. Okay, so first things first, luckily you don't need to change anything, so you're gonna be solving each inequality separately. Okay, so it has to be easy. All right, so as we know, to solve this one, we're gonna be moving 3 to the other side, so we're gonna be having 2x being less than 5. We move that to the other side, it becomes -3, right? So we have 2x, 5 minus 3 obviously is 2, yeah? Okay, so from here we can divide both sides by 2. So these two cancel, so we can say x is less than 2. That's for the first inequality. So we're going to be solving the next one also. So here we have a bracket, so as a note you can take it and use it. First thing, you should always expand the bracket. Okay, so 2 times x is 2x, and then 2 times -1 is -2, like that, and then we have 4, and again move the number to the other side. So 2x is greater than or equal to 4, this minus becomes a plus, so +2. Okay, so this becomes what? 6, and this is 2x, right? As we can see, again, we do have to divide by the number attached to x, so 2. Okay, so we can say x is greater than or equal to 3 because 6 divided by 2 is 3. Okay, so you can copy the and every time till the end. We're gonna write it one more time. So we have this inequality, or let's say set of number, and this set of number. Well, if you're familiar with set theory, you could just say and represents the intersection operation between sets. Even if you don't know that, it's fine, because we're going to be using the number line to actually show the numbers. Okay, so we have 0 here, we have 3, so 1, 2, 3. So this is 3, okay, this is 2. Alright, so the first one says we're going to be using every value that is smaller than 2, okay? So, and also it doesn't have an equal sign, so we're going to be leaving it, the circle like this, empty, okay? So x is smaller than 2, and we know that if you keep going for the left side, having values from the left side, it's going to be every time what? Smaller. So we have to go to the left side like this, okay? So the first inequality says that. The second one says x is larger or equal to 3, and also it has an equal sign, so we can fill this part, okay? Now x is greater than 3, so as we go to the right side, numbers get larger, so it's going to be like this, okay? So you might be wondering, actually, can we actually have a number that is smaller than 2, but also at the same time, because and means at the same time, also at the same time being larger than 3? So no, there is no real value that satisfies both of these, okay? And also these two arrows never meet each other, okay? So there is no value of x that that will make these two arrows intersect each other. So in other words, we can just say the solution set here is phi. Okay, so that means the empty set, because we don't have any value that satisfies this, okay? So don't get confused, because sometimes in mathematics we have this, where there is no value of x that satisfy the thing. So we could just say this is a no solution case, okay? So this is for the first one. You can benefit from the way that we did it, okay? So it doesn't matter wherever the result is. What matters is the way that you solve it. Okay, so in first example, I actually made a mistake. And also didn't pay attention. So we reached this part. We divided by 2, so obviously 2 divided by 2 gives x. And then when you divide the 2 by 2, of course it's gonna give you 1. I forgot I wrote 2 instead of 1. This is 1. But anyways, the result doesn't even change, because instead of using 2 and going like this, okay, instead of this, we circle 1 and go like that, and we said these two never meet, and you have and, so there is nothing in common. You can't have a number that is larger than 3 and smaller than 1, so this result is the same. But I just wanted to point out this mistake that I made, so that you don't mind it when I solve the next one. Okay, so for the or let's say part, it's the same thing basically. So we're going to be solving each inequality separately, and from there we're going to decide the set of numbers that is a solution. Okay, so for x, again, every time you can move the number to the other number. Okay, so moving -7 to the other side becomes what? +7. So now 1 plus 7 is 8. Okay, and this is for x, right? So as always, we divide by 4 actually. Okay, so x is smaller than or equal to, and also 8 divided by 4 is 2. Okay, so I always say this, if you think like I'm doing this quick, of course this is a video, it's recorded, so you can repeat it 1 time, 2 times, 3 times until you get it. Okay, so also this one, so here you don't need to move anything, so you can immediately do what? Divide by 2 again, right? So this is x greater than or equal 12 divided by 2 is just 6. Okay, so we have these two things and there's or in between. Okay, so we have these two set of numbers. Let's see actually what is going to be their final solution set. Okay, so we have the numbers, so 2 and 6, so 1, this is 2, 3, 4, 5, and also we have 6. Okay, right? Okay, so both let's say have this equal sign, so we're going to be filling both like this. So this is 2, that's 6. Okay, now this one says any value that is actually greater than or equal to 6. Okay, so like this, right? So the arrow goes to the right side. Okay, also this one says x is smaller than 2 or equal, so this one goes to the left side. Now can we say that there's no x value that satisfies this? So in other words, is there a number that is actually greater than 6 and also smaller than 2? Well, there is no number that's gonna satisfy both things. But as I mentioned before, if you're familiar with set theory, and is an intersection between two sets. In other words, let's say you're gonna look for a common value of x that works in both inequalities. So that's why we didn't have it here. So we said we don't have such a value, but or represents the union operation between sets. Basically, we're gonna be combining all the values. So the solution set actually this time it's not going to be 5, so it's going to be a real number. So x is a real number where x is either smaller than 2, okay, or x is greater than or equal to 6. So it can't be both, okay, it can be, but like any number that satisfies this, it's either from this part or that, okay? So that's the major difference between and or. When it's and the arrows never meet each other, okay, so that's always going to be phi, unless it's the same number and you fill one. And also, by the way, one thing, yeah, so and this one, when you have the or operation, the difference is it's not going to be phi, because any of these that you choose, it's going to give you a value, okay? So you don't think about them together, so you choose one of the inequalities and you get values, okay? So that's the difference between or and when the arrows doesn't meet. I'm gonna be doing another video where actually the arrows meet, and then we can decide what is the real difference between them.